This is Cloud Technology 101, Cloud Core Values. In this lesson, we will cover customer expectations for the cloud. And what is the cloud, including definitions of the various cloud types, along with the 5 essential characteristics, 3 service models, and 4 deployment models of cloud computing. Before we say anything about the cloud, it's first important to understand what it is the customer will be thinking. There are 3 major characteristics of information security, and we call this the Information Security Triad, or CIA Triad. It includes confidentiality, integrity, and availability. Ironically, within the U.S. Central Intelligence Agency, it is referred to as the AIC Triad. Go figure. First, our customers will be concerned about how their data will be separated from others, with no commingling of data. They'll want to know how we control access and what privacy safeguards are in place. And fundamentally, they want assurance we won't let anyone in. This is confidentiality. They will be concerned about how security is applied each and every step of the way, from session management to secure online storage, from backup to restore. They'll want to understand how we identify users, authenticate and authorize them to the system, secure our network, encrypt literally everything, and fundamentally protect them from the bad guys. This is integrity. Part of the challenges of cloud computing is giving up a certain degree of control and relinquishing that control to a vendor. Customers will want to ensure the system is kept up and running always. They'll want maximum uptime, good performance, great customer support, and a great user experience. They want it to scale with capacity and let them grow as their business grows. This is availability. Last, they'll expect for us to certify our results. They'll expect us to be open and transparent, follow industry standards and best practices, provide confirmation of daily controls, and report back to them that we do exactly what we say we would do. Now that we know what our customer is thinking, the rest of this course and curriculum will consider how we go about implementing these important safeguards for our customers while providing fantastic SAP solutions and the value of perpetual continuous innovations through the cloud. The U.S. National Institute of Standards and Technology defines cloud computing as a model for enabling convenient on-demand network access to a shared pool of configurable computing resources such as networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service-provider interaction. This cloud model is comprised of 5 essential characteristics, 3 service models, and 4 deployment models. The NIST is a U.S.-based organization and has developed these definitions in furtherance of its statutory responsibilities under the Federal Information Security Management Act, or FISMA, of 2002. The NIST is responsible for developing standards and guidelines, including minimum requirements for providing adequate information security for all agency operations and assets. The guideline has been prepared for use by federal agencies. It may be used by non-governmental organizations on a voluntary basis and is not subject to copyright, though acknowledgement is desired. The purpose of this standard is to explain cloud computing technology in plain terms and to provide recommendations for information technology decision makers. Cloud computing is a developing area, and its ultimate strengths and weaknesses are not yet fully researched, documented, and tested. It's important to note that cloud computing provides an on-demand network, a shared resource pool that can be rapidly provisioned with minimal management efforts. These are all defining characteristics and the value of what cloud computing brings to the table. Consider the 5 essential characteristics of cloud computing. On-demand self-service. A customer can unilaterally provision computing capabilities, such as server time and network storage, as needed automatically without requiring human interaction with each services provider. Broad network access. Capabilities are available over the network and accessed through standard mechanisms that promote use by heterogeneous thin or thick client platforms, for example, mobile phones, tablets, laptops, and workstations. Resource pooling. The cloud provider's computing resources are pooled to serve multiple customers using a multi-tenant model with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. There's a sense of location independence in what the customer generally has no control or knowledge over the exact location of the provided resources, but may be able to specify a location at a higher level of abstraction. For example, a country, a state, or a data center. Examples of resources include storage, processing, memory, and network bandwidth. Rapid elasticity. Capabilities can be rapidly and elastically provisioned, in some cases automatically, to scale rapidly outward and inward and commensurate with demand. To the consumer, the capabilities available for provisioning often appear to be unlimited and can be appropriated in any quantity at any time. Measured service. Cloud systems automatically control and optimize resource use by leveraging a metering capability at some level of abstraction appropriate to the type of service. For example, storage, processing, bandwidth, or in the case of SAP, active user accounts. SAP subscription models typically are metered by the number of user accounts, and the subscription fees are based on user accounts. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and the consumer of the utilized service. There are 3 service models in cloud computing, again, according to NIST definitions. Building from the ground up, cloud infrastructure as a service. For IaaS, the capability provided to the consumer is to provision processing, storage, networks, and other fundamental computing resources where the consumer is able to deploy and run arbitrary software, which can include operating systems and applications. The consumer does not manage or control the underlying cloud infrastructure, but has control over operating systems, storage, deployed applications, and possibly limited control of select network components, such as firewalls. To a degree, SAP National Security Services, also known as NS2, may offer infrastructure as a service capabilities as custom configuration for federal customers who require FedRAMP certification. Beyond that, SAP does not have an IaaS offering. Cloud Platform as a Service. With PaaS, the capability provided to the consumer is to deploy onto the cloud infrastructure consumer-created or acquired applications created using programming languages and tools supported by the provider. The consumer does not manage or control the underlying cloud infrastructure, including networks, servers, operating systems, or storage, but has control over the deployed applications and possibly application hosting environment configurations. The HANA Cloud Platform is an example of platform as a service. Cloud Software as a Service, or SaaS. The capability provided to the consumer is to use the provider's applications running on a cloud infrastructure. The applications are accessible from various client devices through a thin client interface such as a web browser, such as web-based email, or a program interface. The consumer does not manage or control the underlying cloud infrastructure, including networks, servers, operating system storage, or even individual application capabilities, with the possible exception of limited user-specific application configuration settings. SAP Cloud Solutions are all software as a service model. No doubt this is confusing, so let's see if we can simplify and provide a better example while having a little fun. What if we could offer pizza as a service? So here are the service models as they align to, well, pizza. First, you have the homemade or on-premises services model. This is the most traditional model, and when done the right way, homemade certainly gives you the greatest degree of power, flexibility, and all the control you need to make your pizza the way you want it. But in this model, you are indeed responsible for everything. You provide the infrastructure, which would be the pizzeria, the kitchen, and the tables, the database and/or services, which is the oven and dough making capability, the application and configurations, which is the sauce, the cheese, and don't forget the toppings, and of course, the overall dining experience, the finished pizza and drinks. Next is the take and bake, infrastructure as a service model. In this model, you provide most everything, but the vendor provides the infrastructure, the pizzeria, the kitchen, and the tables. You provide the database and or services, the oven and dough making capability, the application and configurations, the sauce, the cheese, and the toppings, and the overall dining experience, the finished pizza and drinks. Moving to the next model is the ever popular delivery, or platform as a service model. In this model, the vendor provides most everything, but you still have some responsibility. The vendor provides the infrastructure, the pizzeria, the kitchen, tables, the database and or services, the oven and dough making capability. You provide the application and configurations by ordering the type of crust, the sauce, the cheese, and the toppings, and then the overall dining experience, the finished pizza and drinks. Last is my personal favorite, the restaurant, or software as a service model. In this model, the vendor or restaurant, of course, provides everything you need for a delightful dining experience. In this model, you get a great pizza at a great price, and you are limited only by the creativity of the chef. Most good pizzerias offer a very large selection of pizzas with different types of crust, sauce, cheese, and toppings. At the restaurant, everything is managed for you. I hope this clears some things up, and I hope your SaaS experience is as delightful as it would be, of course, with SAP. Really. Within the deployment models, there are 4 types. Let's explore each one more in depth. First is the private cloud. With the private cloud, the cloud infrastructure is provisioned for exclusive use by a single organization comprising multiple consumers. Typically, that would be business units. It may be owned, managed, and operated by the organization or a third party, or some combination of them, and it may exist on or off premises. The private cloud model is closer to the more traditional model of individual local area networks, or LANs, used in the past by enterprise, but with the added advantages of virtualization. The SAP corporate portal might be an example of a private cloud. External users would not have access, yet it is run by SAP IT for SAP. A community cloud is a multi-tenant infrastructure that is shared among several organizations from a specific group with common computing concerns. Such concerns might be related to regulatory compliance, such as audit requirements, or may be related to performance requirements, such as hosting applications that require a quick response time, for example. The goal of a community cloud is to have participating organizations realize the benefits of a public cloud, such as multi-tenancy and pay-as-you-go billing structure, but with the added level of privacy, security, and policy compliance usually associated with a private cloud. The community cloud can be either on-premises or off-premises and can be governed by the participating organizations or by a third-party managed service provider. The SAP Business Network, formerly the Ariba Network, might be an example as it contains certain aspects of a community cloud. The most recognizable model of cloud computing to many consumers is the public cloud model, under which cloud services are provided in a virtualized environment constructed using pooled, shared physical resources and accessible over a public network such as the Internet. Software as a service offerings such as cloud storage and online office applications are perhaps the most familiar, but widely available infrastructure as a service and platform as a service offerings, including cloud-based web hosting and development environments, can follow the model as well, although all can exist within private clouds. SAP Cloud solutions such as SuccessFactors, CEC Cloud for Customer, Ariba, Fieldglass, and Concur all are SaaS offerings. Last is the hybrid cloud. A hybrid cloud is an integrated cloud service utilizing both private and public clouds to perform distinct functions within the same organization. All cloud computing services should offer certain efficiencies to differing degrees, but public cloud services are likely to be more cost-efficient and scalable than private clouds. Therefore, an organization can maximize their efficiency by employing public cloud services for all non-sensitive operations, only relying on a private cloud where they require it and ensuring that all of their platforms are seamlessly integrated. Examples might be universities that have both private internal cloud concerns, but also have a large public cloud requirement where students and faculty members can share information. In this lesson, we covered what customer expectations are for the cloud. We discussed the CIA triad and how confidentiality, integrity, and availability are key elements for cloud computing. We then provided a definition of what is the cloud based on standards written by the US-based National Institute of Standards, NIST. We also defined the characteristics, service models, and deployment models and provided some examples to support your understanding. This concludes this lesson.